Hello and welcome to episode 150 of our SAP on Azure video podcast. Today is July 6th, and together with Robert and Goran, we are here to talk about anything related to SAP and Microsoft. Hello, everyone.
Hi.
So in the past, we talked already several times about how to protect your SAP system. We looked at zero trust architectures, and we had several deep dives on Microsoft Sentinel for SAP, which also allows you to look inside your SAP system. Another important topic is how you can actually protect your SAP system from DDoS attacks. Preparing for today's session, I did a quick research, and it's actually pretty frightening how easy it is to do a denial of service attack. There are instructions and getting started kits available for everyone. So how can we protect our systems? What can Azure offer me to protect? Today, we have our a frequent guest, Evren, back on the show, and he brings Amir with him, who will tell us more about this scenario. But as always, you know the drill. Let's quickly take a look at some of the news from this week, and we'll get started with some infrastructure topics. Goran.
Yeah, so if you can just share the screen. Okay, now, yeah. So Premium SSD v2 availability. So it's just, we talked in the past v2 about really huge benefit for the SAP customer, sub-millisecond latency. Challenge is always availability in a different region, and here is just actually since yesterday it's announced availability in Switzerland North region, Japan, Korea, Central, South Africa, Sweden Central, Canada Central, and Central US. Again, it is definitely extremely useful for the SAP, meaning especially for the databases. So it's always, this is important. The availability in a different region is important. So just to remind the customer and give them a heads up that we have now availability in those new regions. So feel free, if you are planning to deploy there, just you are warmly welcome and encouraged to use it. The next one, it's also about the security, which a part of the security. So the Azure NetApp has a feature called a double encryption at rest. It is still in a preview. The point is you can encrypt both on a lower level on the physical disk part, as well on the upper level on the volume side, on the software level. So both. And some of customers who are very sensitive on the security do require such a feature. It has a certain impact, or it could have certain impact on the performance. Maybe generally it's 1 to 2%. They are also telling below, if you scroll it down, about potentially maybe even 50%. Depend on the load, which can be sometimes the impact. But generally, it is a highly, from some customer, especially if they are government or maybe the military, they are kind of looking into these kind of, they have this kind of special security feature request. Yeah. So we can go now switch from a lower level to the upper level.
And the next upper level, thanks Goran, is a post from Jürgen Müller, where he talks about basically the SAP AI Core services and how these SAP AI Core services leverage Azure OpenAI, or can leverage Azure OpenAI as the backing service, basically. And he talks about how, again, Microsoft and SAP are working there very closely together, and he has some reference here for GitHub repositories. For example, here he outlines the reference architectures using GPT. So where you obviously have the business technology platform, where you have these SAP AI Core services, and where from Microsoft Azure, you then consume the Azure OpenAI services, and where this is really a reference case on which customers, partners can build application. One of these applications, for example, is this smart CO2 or CO converter, which basically follows this reference architecture paradigms, but then adds obviously some business logic on top of this. So, for example, in this case, and there's some nice screenshots here. The idea is that you can actually track your CO2 footprint here, make sure that things that are yeah, that are relevant in your life, basically, that they can be tracked here via this monitor. So it's a nice CAP, a cloud application programming model that follows this paradigms of using the SAP AI Core services, and from there consuming Azure OpenAI services. And speaking of CAP, so the cloud application programming model, we actually had a hackathon yesterday, a community-driven hackathon in St. Leon Roth, together with SAP and lots of customers and partners, where the idea was to build a connector for CAP for Cosmos DB. So as of now, CAP officially supports the HANA database. There's a community adapter for Postgres. And basically what we try to do in this hackathon was to also extend the capabilities of CAP to consume NoSQL, and in our specific case, the Azure Cosmos DB database. It was really a cool event. We had lots of really fantastic developers there that really got excited and started to develop these scenarios. We had some amazing folks from SAP there that helped us. We had a lot of colleagues several colleagues from the Cosmos DB team there. So I think, right now it's all in a private repo on GitHub, but I'm sure in the next few days we'll also make this public, and then others can also contribute. Speaking of blog posts, Martin Pankratz has released yet another blog post. Actually, this one was just released when we finished recording our episode last week. So just a quick recap. It's about the SAP S/4HANA Cloud ABAP Environment, so Steampunk on BTP, which is now available also on Azure. And Martin is focusing on what can you do now with the ABAP environment here. And he has a nice showcase, actually, where he's using a travel booking service. So he's guiding you through the required steps to set this up in Steampunk. And then when you have the travel request, then you can actually approve this via a logic app in Teams. There's also a write-back scenario or callback scenario there. So if you want to test out the ABAP development environment on Azure, then yeah, just follow this blog post, and I think it's a really nice scenario. Martin actually also published another blog post just today, or actually he updated one of his blog posts mainly with some additional playbooks that were just released. So this is all in the context of Microsoft Sentinel and the SAP adapter. And obviously for the SAP adapter, you have a collector agent that connects with your SAP system that really allows you to look inside the SAP system. And now it's the whole story is even one step further. So it's not only monitoring, but actually what happens if someone attacks the collector. And he created, together with the team in Israel, he created a really nice playbook that now also allows you to monitor this connector. And actually, when something happens, then you get a nice adaptive card in Teams. Where is it? I saw it before. Maybe it's just here. So a nice adaptive card is posted. Well, I don't see it right now, but and then the team gets a notification. Then they can react whether it is something where it's potentially really an attack, or where there's maybe a natural explanation why the collector was stopped. So that was basically all for this week, which is perfect, because I think we have another really great topic today on our show. So I guess everyone still remembers and knows Evren, but still, if not, maybe Evren, you can start quickly introducing yourself, and then Amir, maybe you can do the same. What are you doing at Microsoft? And then, yeah, I'm really looking forward to the DDoS presentation.
So would you like me to share my screen at the same time, Holger?
Whatever you like. You can already get started.
Okay. All right. So let me share my screen, and then we can actually just go with the intros. Let me minimize my screen, and let me know if you can actually just see our slides.
Yes.
Okay.
Working.
Hi, Holger. Hi, Goran. Nice seeing you guys. As you guys know, my name is Evren Buyruk. I'm a senior CSA from Microsoft SAP account. I cover apps and infra, and mainly security for applications hosted on Azure. So I'm one of the technical leads for SAP Connected Community. So today, I also have my colleague, so my trusted advisor, somebody that actually knows the topic more than me, Amir Dahan. So Amir, why don't you introduce yourself?
Yeah, sure. Thank you. Hi, everybody. Great to be here, and thank you, folks, for having this opportunity. I'm Amir Dahan. I'm part of the DDoS product management team, located in Tel Aviv, Israel, and it's my pleasure to join this session and support Evren and you guys on some details on DDoS, which I think it's exciting.
Perfect. Well, thanks for joining us today.
Thank you. So should I go and just get this started, Holger?
Yes, please. Yeah.
So again, thanks so much for this opportunity. It is so big privilege to be here. So today, Amir and I will cover the DDoS protection services for SAP and even non-SAP workloads in Azure. So we will discuss the infrastructure-based protection versus the network level protection, which actually just like Microsoft provides in 2 different SKUs, and we also have IP protection SKU. We are also going to be talking about that. So we have a short demo. We're going to show you how to enable the solution on Azure portal with the thresholds. We will be providing you with really deep analysis on what the solution is about, why we need it. So we will also just like, introduce the newly launched DDoS for Sentinel. So basically we're going to be talking about that. So before we start, I am actually just going to be speaking about the simplification of the security management with Azure services. Although that we know that our topic is Azure DDoS protection services for SAP. So instead of jumping right into the Azure DDoS, we would like to first talk about the Microsoft approach to Cloud DMZ. So what exactly is Cloud DMZ, the concept of DMZ? So basically, demilitarized zone is a layered network security approach to minimize the attack footprint of any application. Basically, a DMZ architecture is comprised with either 2 layers or 3 layers of security and protection concept with additional user-defined routes and firewall rules. Basically, what we say is that Azure network traffic to and from resources in a virtual network using network security groups, network virtual appliances. These are all the major components of the Cloud DMZ. But when we are looking at the DMZ in a deeper level, it is really enriched with Microsoft native solutions, not only about the network security groups and then application security groups. It is more on the component level to make sure that the investment on Azure, any application investment on Azure is going to be actually augmented with Microsoft native security solutions, which is under the concept of the zero trust security. So the zero trust provides a modern security framework to manage the complexity of any organization today. Basically, the holistic approach to zero trust should really extend throughout the entire digital estate. So it is going to then serve as an integrated security philosophy and end-to-end strategy for any customer that would like to secure their applications and data on any cloud platform. And in our cloud, it is Azure, Microsoft Azure. So you can do this by implementing the zero trust controls and technologies across 6 foundational elements, which are like identities, which is something that we are really just prioritizing it. And then we actually just put it forward because whether they represent people, services, or IoT devices, it really defines the zero trust control plane's foundation. So when an identity attempts to access any resource, we need to verify that identity with strong authentication, and then we also ensure access is compliant and typical for that identity. And then it also just follow the least privileged access, principles. So when we're talking about the IAM or identity access management solution, we are providing our customers with best-in-class, best practices. Basically, we are not necessarily just like letting our customers to use Microsoft Azure Active Directory, for example. We are also providing via our cloud solution architects, providing the customers with the best practices, how to configure the maximum augmented Azure Active Directory or IAM solutions for their SAP, even non-SAP applications. So for the 6 components that I mentioned, that the devices are important. So because once an identity has been granted access to any resource, the data can flow to a variety of different devices. So from IoT devices to smartphones, it might be bring your own device to partner managed devices. If a partner is providing support for the customer, so then the partner is going to be leveraging customer sent or customer provided devices or their own devices. So then they can actually just manage the customer's environment. We also have the on-premises workloads to cloud hosted service. So we also need the authentication and authorization for those devices as well. Basically, this diversity creates a massive attack surface area. So it requires that we monitor and enforce device health and compliance for secure access all times. So of course, the data component of it, ultimately, security teams are really just focused on protecting the data. So where possible, Microsoft recommends that the data should remain safe, even if it leaves the devices. Basically, it might be the app, it might be infrastructure and network for the organization controls. It needs to be protected at all times. So data should be classified, it should be labeled, and it should be encrypted and access restricted based on those attributes at all times. So there's no compromise on that. There's no sacrifice on that. Then the applications, of course. Applications and API provide the interface by which data is consumed. They may be legacy on-premises, lift and shifted to cloud workloads, or modern SaaS applications. Controls and technologies should be applied to discover shadow IT. So it should ensure appropriate in-app permissions, so gate access based on real-time analytics, and it should be monitoring for abnormal behavior, and it should also just control the user actions and validate secure configuration and options. So of course the infrastructure, which we are actually just looking at it today in a very deeper level, because infrastructure, whether on-premises servers or cloud-based VMs, it might be containers like AKS, for example, or even microservices like Logic App or Azure Data Factory. And then it might actually represent a critical threat vector for any customer today. Basically, we have to assess for version configuration, in just-in-time access to hardened defense. We have to use telemetry to detect those attacks and even anomalies. So basically, we have to automatically block and flag risky behavior at all times. So we have to take protective actions. So what we do throughout Microsoft journey when a customer comes to Azure, we are providing them with best-in-class infrastructure best practices. Basically, we don't necessarily just give them the templates, and we don't ask them to go ahead and just deploy those templates on their Azure portal. We are actually just asking them to go ahead and just use Azure best practices on how to augment, secure the infrastructure investment on Azure so they can get the maximum benefits from that. So of course the network, as I mentioned in infra. So all the data is ultimately accessed over the network infrastructure. It is for sure. Basically, networking controls can provide critical, we call it in-pipe controls, so that you can enhance the visibility and you can help prevent attackers or the bad actors from moving laterally across the networks. So basically, what we recommend our customers is that networks should be segmented all times, including deeper in-network micro-segmentation, like NSGs, for example, that we use from application to database communication, that we are actually just creating subnets to make sure that this application and database connectivity is going to be secured, is going to be access controlled. Basically, we are providing the real-time threat protection and also end-to-end encryption when it comes to the network. So I got a question from one of the customer when a customer was considering Azure, they asked me how it is going to actually just, enable them to provide secure data replication in Azure data centers. So they asked me what kind of a protection it is. And I said, it is the MACsec, basically media access control security. It is the IEE standard, is going to be IEE 802 standard. Basically, data or the communication from point A to point B is going to be secured at all times with IEE. Basically, it's going to be the MACsec. So, and then the data at rest is going to be AES base 258. Basically, it is going to be protected at all times. And then the customer is not necessarily going to just, really just worry about how the data is going to be secured when it comes to just like, holding the data on Azure, making sure that data is not necessarily is not breached or is not compromised. So basically, while we are giving the customers this kind of like a feedback, we're also just giving them the, policy-driven access recommendations. Basically, modern micro segmentation, it already just means that more than networks to many customers today. So because it requires the customer, provide themselves with gate access based on role, location, behavior patterns, and data sensitivity, and then client application and device security. Basically, customers ask Microsoft our best practices, and then they know that Microsoft actually just provide them with best-in-class, recommendations. It is important to ensure all the policy is automatically enforced at the time of access, and it is going to continuously monitor and then apply all those policies throughout the session where possible. So of course that we have the visibility, analytics, and automation components as well, as we are providing telemetry from the systems. And then these actually just like, must be processed and acted on automatically. So we give our customers the best practices on that as well. Basically, attacks happen at cloud speed, as we know. So customers' defense systems must act at cloud speed as well. So there's no question about that. Basically, in human, just can't react quickly enough. So we are actually just using this telemetry and AI to make sure that the systems are protected, and then it is integrated with intelligence, with policy-based response for real-time automated threat protection. Basically, I'm just giving example how Microsoft is treating these technologies from a broader perspective. We're not necessarily just talking about the Azure DDoS, as it is going to be protecting the customer's overall network. We have a lot of solutions, a lot of sections that you already just see in this slide, and Azure DDoS protection is one of the most important components. And then we're gonna be actually just like, telling you the reasons why. So in 2022, Microsoft mitigated an average of 1,435 attacks per day. So the maximum number of attacks in a day recorded was 2,215 attacks on September 22, 2022. This was also just like, publicly shared. So
in one day.
In one day.
In one day.
Exactly. So the minimum number of attacks in a day was 680 on August 22, 2022. So in total, we really mitigated upwards of 520,000 unique attacks against our global infrastructure during 2022.
Wow.
So this year, that is very interesting that Amir and I were talking about that. We saw the lower volume of attacks in June through August last year, I'm talking about, and a high volume of attacks during the holiday season until the last week of December 2022. So this is in line with attack trends we have seen in the last few years, except for 2021, where there were fewer attacks during the holiday season. So in May of last year, we mitigated a 3.25 terabits per second attacks in Azure. Basically, that was the largest attack in 2022. So TCP attacks were the most frequent form of Azure DDoS attack encountered in 2022. It is comprising around 63% of all attack traffic, which included like all the TCP attack vectors. So why it is important? TCP, SYN, TCP ACK, TCP flash, etc. These are all very major components for DDoS, denial of service attacks, and then it actually just becomes the center attention for a lot of customers throughout the world, because TCP remains the most common networking protocol still. Basically, we expect TCP-based attacks to continue to make up most DDoS attacks going forward. So basically,
yes, and Evren, to add to that, I think that talking about the number of attacks we're actually mitigating on a daily basis. I mean, think about the mitigation capacity we need to put in place, right? And you mentioned more than 30 terabits of terabits per second of attack mitigation that we've kind of mitigated in the last months. Now, if you consider that, this means we need to put huge scrubbers in order to be able to cope with these attack capacities. And indeed, this is the case. We have, like, I think, aggregated more than 80 terabits of aggregated attack mitigation capacity that is distributed globally in Azure in order to protect those capacities. Now, this ensures that not only we can mitigate these largest multi-terabits attacks, but we can also mitigate multiple very large attacks concurrently to make sure that Azure is safe and the customers are safe.
Exactly.
Amazing.
And also, in addition to the TCP attacks, we also just saw the UDP attacks. They were also significant as well, because with 22% of all those attacks, combined for UDP flood and UDP amplification attacks, also added to the TCP attacks as well. So basically, we got a really good number for TCP and UDP altogether. So while packets anomaly attacks made up 15% of those attacks. So basically 15%, it was the anomaly attacks, and then 22% was the UDP attacks. And then we got like total 63% of the attacks traffic. So including like TCP and then UDP and also like the anomaly attacks. This is something, is a really big number. So then, of course, when this happened, customers started just come to Microsoft and say, hey, we would like to get a protection for the brute force attacks, which is nothing to do with DDoS. So the reason why I'm showing this is because we got lots of requests from customers about their concerns on brute force attacks, because some customers do not necessarily know the difference between the brute force attacks and also denial of service attacks. And then we have the solution for that. And then we have some best practices to prevent the brute force attacks from happening. So now, what is brute force attacks? Basically, these are different from DDoS attacks in that they are not designed to overwhelm a system with traffic. Instead, they're designed to gain access to a system by trying every possible combination of characters or passwords. Basically, this is less professional than DDoS attacks because it is a trial and error method used by any hacker to guess credentials or encrypted data, such as login, passwords, or encryption keys through exhaustive effort, which means that like using brute force attack. Basically, when we say exhaustive, effort is all about the brute force attack, because it is going to be trial and error with the hope of, eventually guessing it correctly so they can go ahead and just hack into the system. So the brute force attack is one of the most popular password cracking method for hacking WordPress today. So if a person is actually just running their, website on WordPress, and then this is something that brute force attack is really just used. So customers come to us and say, hey, what can I do to manage my, my system. And then when it comes to managing Azure VMs, so what should I really just do? So basically, in a situation like that, administrators usually use remote desktop for Windows, or we are like, leveraging Secure Shell for Linux, for example, so that we can remotely connect to and manage them, right? So what happens is the initial method to get access to these VMs was remote desktop protocol, brute force attacks. Basically, this is going to consist of checking all the possible usernames or passwords until the correct one is found, and then the person actually just is in the system. So this isn't the most popular, or sophisticated form of attack, but it is relatively simple to perform, and given enough time, it really just works for some people. Yeah. So what is the advice, right? The advice is, let's say we are just going to blunt the access, or we're just going to make it hard for them, so they can take multiple measures. When I say they, customers can. So such as they can disable the public IP address using, point to site virtual network, VPN. They can do site to site VPN. They can do Azure Express Route. They can use Azure Bastion. So they can require two-factor authentication. So they can also use complex passwords, and they can limit the amount of time that the ports are open. So these are the majority of advices that we are given to customers when it comes to brute force attacks. Basically,
by the way, Evren, just a comment. Internally in Microsoft, we are not allowed to use the public IP address for this reason. So meaning either Bastion, I like the point to site VPN, for example, it's quite nice. Once by accident, I enabled the public IP address on the Linux, and it was immediately, brute force attack, with the root user, try to log immediately, kind of really. So it's really crazy how something, when something is publicly available, how can be immediately attacked. So it's really, this is a super important information and
exactly. Very awesome point. Awesome point. Yeah, that's why we don't allow public IP. Yeah, that is correct. And then when a customer reached out to me last year, and then they asked me, hey, I'm just going to mark it down. Give me all the advice that you can actually just give. What can I do to blunt the brute force attack? I said, disable the public IP address, as Goran actually just mentioned. Use point to site, virtual private network, which is VPN. Create a site-to-site VPN. Use Azure Express Route, and then again, just use multi-factor authentication, MFA, and then also increase the password length and then complexity. Like here is the example: the ZTYN, then %9, and then bunch of other things that you can actually just add. Like I like eth, for example. It actually just makes it more complex. And then we also have the CAPTCHA, which is actually a completely automated public tuning test, which stands for, lots of people actually just will wonder, what is CAPTCHA? It is completely automated public tuning test is CAPTCHA. Basically what CAPTCHA does, anytime you let people register on the site, on their website, or even enter a name and URL like a comment, you might get a flood of fake names. So basically, these are often left by automated programs, which is called bots, that I'm actually just going to be talking about that. They try to leave the URL on every website they can find. Basically, the motivation around it is that it actually can post the URL of products for sale, for example. So you can help make sure that a user is real person and not a computer program by using CAPTCHA to validate users when they register or otherwise enter their names and sites. Most of the time, hey, show me the fire hydrants, or show me bridges, show me motorcycle, people wearing helmets on the motorcycles, for example. You can also just make it difficult. Not only, hey, show me the rivers, or show me the mountains, or show me beautiful places in Israel, Tel Aviv, where Amir is actually just coming from. No, make it more complex, right? Hey, just show me the mountains and just make sure that the mountains are like rivers. So the person is going to really differentiate between mountains and rivers and make sure that they can actually just decipher the common sense, picture, and they can mark, mountains, 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 and go hit and next and just go. So that is one way to eliminate the computers to do that, because you need human perception to actually just make sure that the selection is correct, which is something that is very important. So bottom line is, if anyone is wondering how I can blunt brute force attacks, there you go. Pause it on YouTube in this second. Just take a screenshot of this and just put it on your desk and just apply these best practices. You're going to be actually just mitigate the risk for brute force attacks. So now the topic is distributed denial of service, DDoS. So we're going to be actually, as you guys see that we started from simplification of Microsoft security management all the way to brute force attacks. And now we are just coming now to DDoS protection. A denial of service attack is an attack that has the goal of preventing access to services or systems. This is the entire reason why DDoS actually just exists. So if the attack originates from one location, it is called DOS, DOS, denial of services. If the attack originates from multiple networks and systems, it is called distributed denial of service. Distributed, because it is not in one location, it is distributed across multiple locations. So before learning more about DDoS, so what exactly it is, so we need to really just know what botnets are, because botnets are, as I mentioned in the previous slide, these are the collection of internet connected systems that an individual controls, and it uses without the owner's knowledge. This is so important, because botnet owners use them, or the generators of botnets are using them to perform various actions on their, choosing. Basically, they use them for spamming, data storage, DDoS, or they can actually just use them for various other actions that are up to the person in control of the botnet. So we have no control on how the owner of the botnet thinks, but we can just see that they can do it for spamming, they can do it for data storage, they can do it for DDoS, and then again, they can be doing it for any reason. That person might be just doing it for fun, but it is not fun for the customer, because we actually just saw that in the past, botnets were made up just compromised computers. But now botnets are also made up of Internet of Things, IoT devices. So lots of customers are leveraging them today. So malicious, I wouldn't say that hacker is a malicious or hacker is ethical. I'm an ethical hacker myself, so I'm certified on that. But there's also the malicious hacker, which I am not. So we are actually just trying to make sure we are not going to let those malicious hackers can get those poorly secured systems like IoT devices, even the security cameras, digital video recorders, even thermostats or other internet connected devices under their control. So basically, any customer that is leveraging remotely managed thermostats, for example, like coffee shops, some coffee shops are some of them are using those. Basically, they're centralized and they're actually just doing the management of those thermostats remotely. What if that somebody has access to those? So then how it is just going to really just work for the customer, because the internal supply chain management can actually just be breached by that, by just having access to the thermostat. Why? Then the brute force attacks can actually just happen on the other side. So the person can guess the access. They can actually just spoof the system. Basically, there are lots of areas where DDoS is actually just can be used, even with the combination of brute force attacks. But it's really a collection of attack types aimed at disrupting the availability of the target. You can actually just do it multiple ways, as I said, just getting connected to the thermostat or security cameras the company just uses, which is connected to the internal network. So these attacks involve a coordinated effort that use multiple internet-connected systems, so they can launch many network requests against, it might be DNS, it might be web services, it might be email, even more, pretty much everything. Because any application that the malicious hacker can access might become the target for a DDoS. Again, it might be anything. So these people...
Evren, to add to that, I think one thing I wanted to highlight, we are going to publish Microsoft Digital Defense Response for report for FY23. And in terms of a DDoS attack landscape, what we are seeing is that, when people talking about bots, they, as you mentioned, they refer to IoT devices that are compromised, etc. But we started to see this year the new generation of bot networks, and those are what we call our hypercloud bots. What we are seeing is that bad actors try to abuse subscriptions in hypercloud platforms and leverage those subscriptions to create bot networks that are compromised, and then use those bot networks to launch various cyber crimes. DDoS is part of them, right? So this means that bots are now coming from everywhere, and the hypercloud bots, those are more powerful. They can inject more traffic because they are built on cloud compute resources. And customers that are using our DDoS services, those customers are protected against these hypercloud attacks coming from outside of Azure, because we actually can detect and mitigate those attacks. And not only that, we will know and we will detect and mitigate attempts from bad actors to compromise subscriptions of Azure customers that will otherwise give them the opportunity to launch DDoS attacks from within the subscriptions of our customers. So that's one point I wanted to mention. And the second one is what we call the year of the activist. Starting the Russian-Ukraine conflict, we start seeing even last year a ramp up of attacks from Killnet and lately Anonymous Sudan, which are affiliated, that started to launch attacks on Western countries and those that kind of opposite to the Russian side in the conflict. And we kind of tracked some of those attack patterns on applications running in Azure. And we took, for example, the healthcare vertical, which is kind of one of the hotspot verticals to Killnet and other affiliated cyber crimes. And we see an increase of pattern in terms of the number of DDoS attacks launched on those customers that are representing the governments of those Western countries that they want to bring down. And this is also important because we will see later, when we actually create a DDoS protection policy, we set detection thresholds that are unique to the fingerprint of the application we protect. And if customers are not enrolled to DDoS protection, those attacks will go below the radar of the default infrastructure level protection and will come and hit the application. So this is why it's very important to be protected with Azure DDoS services.
Exactly. And they're also than before because of the increase in numbers of connected devices as well. But again, it's not only about IoT devices anymore. So it actually just evolved its effect. So it's actually just becoming more and more important. So basically, what do we have from Azure side? How can we help customers, right? So this is the reason why we are here today. Of course, that we actually just had to make it like clear to the audience that when we are talking about the security controls, DDoS is one of them, but we have to just like compile it to the bigger picture. And DDoS is going to be becoming very important for any customer. And I'm actually just going to be mentioning about the importance of that in a different aspect in the next slides. Is actually, very next slide actually. And I'm gonna be talking about why it is important. But now let's see what Microsoft does on this topic. So Azure provides built-in infrastructure level Azure DDoS protection So this is to protect against DDoS attacks targeted Azure platform and Microsoft Online services. So infrastructure level DDoS protection protects any resource in Azure, regardless. If a customer comes to Azure, they are going to be provided infrastructure level protection, which used to be basic protection. Correct me if I'm wrong, Amir. It used to be basic. Now it is the infrastructure level protection. Am I correct on that?
You are correct.
So basically, what it does, previously basic, now infrastructure level, is ensuring that when a customer application is attacked, there's no impact to other customers in the same data center and region. So in an event of DDoS attack, infrastructure level protection is really designed by default to prevent impact on the Azure platform so that the detection policies and thresholds are, intentionally high. Basically, application target attacks can bypass the infrastructure level DDoS protection since the attack throughput is often lower than the infrastructure level protection detection thresholds. So that doesn't mean that when a customer moves to Azure, hey, Microsoft already just provides me with infrastructure level protection, I'm good. You're not, because it can still bypass the application layer. So
in fact, Evren, what we see when we track what the DDoS trend and the attack landscape, what we see that in the majority of cases where customers were attacked by DDoS attackers, we see that the volume of attacks in those cases was medium. It wasn't that high, which means that attacks were able to easily bypass and go below the radar of the infrastructure level protection. And this is the main risk here. And this is why customers need to onboard to Azure DDoS protection services, because we are fine-tuning the DDoS protection policy to the exact behavior and patterns of their application running in Azure. And each customer has different application with different traffic patterns, with different amount of compute resources, and we must make sure that the DDoS protection policy exactly matches each specific application. Otherwise, if we go with the infrastructure level protection, the thresholds for detection are so high that we want to protect the region, the data center. We don't really care. I won't say that we don't really care, but from our perspective, we want to make sure that the Azure itself, the Azure platform, is protected, but we cannot protect each and every application. This type of protection is provided to customers that enroll to our DDoS protection services.
Exactly. So that's why when a customer is reaching out to us and ask us, hey, what is the recommendation? Then there is going to be the network level protection, because they will need this DDoS protection that is going to be dynamic, that's going to be designed to protect against attacks at their application. So for enterprise grade applications, like mission critical applications like SAP, our customers are asking about like, hey, what is the best solution for native platform integration? They would like to actually just like, natively, they would like to know the solution is going to be natively integrated into Azure. It's going to be configured through the portal. They're looking at like turnkey protection, for example. What it means, they would like to have simplicity or simplified configuration, protecting all the resources immediately. So they're looking at always on traffic monitoring. So they would like the application traffic patterns are monitored 24/7, 7 days a week. So they're looking for indicators of DDoS attacks constantly. So, and they would like to, as Amir mentioned, that they would like to do the tuning on it, like adaptive tuning. They would like to do the profiling and adjusting to the services traffic, how their services actually just enable. For example, when we're looking at the application gateway, it is for layer 7. There's a detection mode and there's a protection mode. So when we are actually just asking our customers, hey, go ahead and just like, run your application gateway version 2, and then start it on detection mode, and then switch it to the protection mode later on. They ask us why. Because application gateway is going to have the smarts inside to learn the traffic patterns. So it can actually just learn. Once it learns within a month, 20 days, a month, 40 days, depending on the customer traffic pattern, the administrator can actually just switch it to the detection mode so that now it can protect the environment based on the traffic patterns. So DDoS is doing exactly the same thing. So now I'm going to be talking about a correlation between application gateway and DDoS, why it is going to be even more interesting for the customers. So why they should be actually just enabling it. So basically, it is going to be giving them multi-layered protection once they have the network level protection. Basically, when deployed within web application firewall, DDoS protection standard, it used to be standard. Now it is network level protection, both at the network layer, which is layer 3 and layer 4, offered by Azure DDoS network level protection. And at the application layer, layer 7, offered by WAF, is going to actually just give them comprehensive solution for accessibility or access protection. Basically, this is going to be actually just, this slide is actually just going to give a better view. So lots of customers would know about this, architecture. So now why it is going to be becoming even more important, because when we're looking at the overall deployments on Azure, customers are looking at hub and spoke configuration, basically the hub VNet, so which is an Azure VNet used as the hub in the hub spoke topology. So the hub is becoming the central point of connectivity to on-premises network and a place to host shared services that can be consumed by different workloads hosted in the spoke VNets. So basically, the hub VNet that we're talking about is typically mapped directly to an IT subscription to provide network transit, express route gateway, VPN gateways, even MVAs, third-party MVAs. It can be security, it can be identity services. You're containerizing all these technologies into the central point of connectivity to on-premises, which you guys actually just see. The hub is actually connected to the customer side, which is going to be the starting point. So then the spoke VNets that we are just going to be looking at here, this is going to be something that is going to be important for the customers, is because one or more Azure VNets are going to be used as spokes in the hub and spoke topology to expand. Basically, spoke VNets are going to focus on the tenant workloads. So these spoke VNets could be representation of different application states, application stacks. It might be departments or line of businesses. So is it common for IT and security professionals to be granted role-based access control to these spokes to maintain infrastructure components such as VNets, network security groups, route tables, and so forth. So spokes are important as they can actually just be used to isolate the workloads in the VNets. So it is going to be managed separately from other spokes. So each workload might include multiple tiers, multiple subnets connected to Azure load balancers. So then the traffic is actually just going to be done let's say the application gateway load balancer, the backend servers are just going to do all the, load balancing using, application gateway. But what about this guy, the hub network? So the hub VNet, hub virtual network is going to have, like in this example that we're looking at Azure Firewall, application gateway, express route virtual gateway. What is going to protect these guys? So lots of times customers do not think Azure Firewall does not need to be protected because it's an Azure Firewall. Application gateway shouldn't be just even worried about it. Though the answer is no, because once we actually just have all this assets on Azure, we have to just make sure that everything that you are actually just putting in the VNet has to be protected. So the protection to enable here is going to be the DDoS network level protection. Is going to be, first of all, providing your firewall. Is going to be providing any of the assets that you actually just put inside. For example, gateway subnet, express route virtual gateway subnet. This is required to build a virtual network gateway. So what we do is that we allocate, let's say, the 32 addresses to the subnet. Will help to prevent the, let's say, from the best practices reaching gateway size limitations in the future. But then accordingly, we are just going to make sure you can actually just expand. Yeah, from the best practices, everything is okay. You're going to be allocating /32. So it is going to give you the expansion. But how are we just going to protect this, virtual gateway, which is actually the first component of the hub from central point of connectivity to on-premises, then application gateway. You're going to do all your inbound HTTP, HTTPS traffic coming to application gateway. For Azure Firewall, and then you're leveraging Azure Firewall and application gateway side by side using the route tables to verify the source IP address. Everything is going to be undermined. Everything is going to be overshadowed if you're not protecting this component here. So to protect that, the solution is going to be DDoS network level protection. It is going to actually just provide you with the protection for the component on the Azure resource. Basically, let me just go to the next slide.
Actually,
so here,
Evan,
yeah.
Looking at the time, what about jumping to the demo and taking a look?
Exactly. We are actually just going to do that now.
Okay.
I'm actually just going to be wrapping it up with this and then turn it over to Amir, and then also just gonna show the snapshots. Basically, from enabling Azure DDoS protection on Azure resource is actually something that is going to be very easy, is straightforward to enable. So we are actually just going to show how to do that, and then that's going to be part of the demo as well. Basically, we're going to look at creating a resource group, creating a DDoS protection plan. We're going to do the enable DDoS protection on a new or existing virtual network, configure DDoS alerts, configure diagnostic logs, and then we are just going to run a test DDoS attack and monitor the results. This is the overall best practices when a customer is looking at how this can actually just be enabled. So from the implementation perspective, again, this actually is pretty much the overview on the differences between the infrastructure level and also the network level protection. Basically, once it is enabled, the customer is actually just going to get the fine tuning on the application layer, so they can actually just use it effectively. So then this is something that actually is becoming more and more important, why customers are looking at DDoS protection. When a customer is looking at DDoS protection, network level protection, and then once they have the application gateway, Azure application gateway, and then WAF component on top, it is going to be providing the customer with 100% discount on the WAF component. So now, if a customer is protecting the hub VNet with the DDoS network level protection, that protection from DDoS is going to discount the WAF component on application gateway. This is something many of our customers don't know. Now they can actually just know. They can say assured Microsoft is not going to charge them for the WAF component on application gateway SKU once they enable Azure DDoS network level protection. So this was actually just very important. So with the application gateway for any application on Azure, they can still just use the front end configuration, backend configuration. They can protect their resources which are load balanced by application gateway, so they can enable the WAF component on top, and then Azure DDoS network level protection is going to discount that WAF component on top. So then from the configuration perspective and everything is going to be the same, nothing is going to change from application gateway configuration perspective. Customers are still going to be leveraging default health probe, custom health probe, and probe matching. And then they're still going to be able to actually just use the best practices as application gateway by default monitors the health of all the resources in its backend pool and automatically remove any resource considered unhealthy from the pool. So that it's going to continue to monitor the unhealthy instances and add them back to the healthy backend pool once they become available again. So basically nothing is going to change from the configuration perspective. So then some customers are looking at the overall price components, and some customers are saying that, hey, I don't really have that many IPs. Can I use the IP protection, which is actually the new SKU? So for Azure DDoS protection, that is designed for SMB customers, small, medium businesses. in mind. So it is delivering enterprise grade and cost-effective DDoS protection. And then there's also a slide which we actually just put together that shows what exactly the difference between these two guys. This is very important for customers to really just know. DDoS network protection covers everything. And then Azure DDoS IP protection is not necessarily providing DDoS rapid response support, cost protection, and WAF discount. The cost protection component is important. During the attacks, customer is not charged with DDoS network protection. There's guarantee that the credit is going to be back to them. But with the Azure DDoS IP protection, there's not that component. Plus, the DDoS IP protection does not have the WAF discount enabled. Basically, if you're leveraging Azure Application Gateway with WAF component, which is mod security, and then you would like the discount to be applied, it is not going to be possible with DDoS IP protection. It is going to be possible with DDoS network protection is going to be providing that discount. Now the demo, and then we are actually just going to be, finishing it here. So this is important is we ran the demo right before the, presentation. Basically, we use the breakpoint cloud to simulate attack on our, Azure firewall and application gateway in SAP S, which is Security Operations Center resource group. So in target IP address, we specified either on these public IPs ending with 248 and 163. So 163 is the application gateway public IP. This is the IP that we used. Basically, we used application gateway public IP, and we did the flood on this IP. We chose 443. We chose DDoS profile TCP SIM flood and did 200K PPS at 100 megabyte per second. So we use 8 source IPs because we have to do remember, distributed denial of service attacks has to be originated from multiple locations. So that's why we use 8 source IPs. So SIM flood, the reason why we did the SIM flood is a form of denial of service attack in which an attacker rapidly initiates a connection to a server without finalizing the connection. This is one of the easiest way for the malicious, person to do that, because the reason is that the server has to spend resources waiting for half-open connections, which can consume enough resources to make the system unresponsive to legitimate traffic. So we also have the Simple Service Discovery Protocol, which is SSDP attack. That's a reflection-based distributed denial of service attack that can exploit universal plug and play. So basically, here in this example that you saw that within 10 minutes, frames per second sent is 174,651. So the last round result is actually frames sent 142 million is actually frames sent, and then the megabit per second throughput achieved is 95. Basically, with the DDoS network level protection, our customers are really just, as you can see in this slide, this is a very recent demo, which is like 10 minutes ago, 10 minutes before we started presentation, because we didn't want to wait 10 minutes in this presentation. We're already running out of time. But now we're going to be showing you how to actually just get the thresholds and then configuration and how to enable that. So I'm just going to now turn it over to my colleague, product group, and then amazing Amir to actually just show the thresholds.
Thank you, Evren. Let's do a quick demo. Let me share my screen quickly. Okay, do you see it?
Yes, it's coming up. Yes, perfect.
Okay, great. So what I want essentially to show here is how easy it is to enable DDoS protection on a resource, right? And then to look at some of the interesting metrics we have. So what I did here is created a virtual machine, and that virtual machine has a public IP address, which you see here. And remember that in DDoS, what we actually want to protect, we want to protect the public IP address resource, because this is the resource that is getting the traffic, the DDoS traffic from the internet. So the way to enable DDoS for it is to go to the public IP address resource that is associated with that specific VM, but it can be load balancer or firewall or application gateway or whatever. And when you go to the virtual machine public IP address, you can first assess what is the DDoS protection that you are having on that resource. And in this case, you see the DDoS protection status is unprotected, which means that we are trying by default to take the DDoS protection from the network. If the virtual network of that virtual machine is protected by the more premium SKU, which is DDoS network protection SKU, we will take the protection from it. Otherwise, it will be unprotected by default. So this is the situation right now. And in order for me to enable DDoS protection, what I can do is simply go to protect IP address, click on that, and then I'm getting a configure DDoS protection configuration plate. You see the reason for the unprotected status. The virtual network is not connected to DDoS protection plan. Connect the virtual network to a DDoS protection plan to receive protection. This is the DDoS network protection SKU, the more premium one. But I want to use the DDoS IP protection SKU, which is the new one that we've just launched for GA in last April. And I'm going to click the IP protection SKU and save. Now, what's happening in the backend, right? And it will take like a few seconds for it to enable. What we are going is we are actually start to building the policy for that specific public IP address, and that policy will have its own detection thresholds. They will start with some defaults that we put for that specific component or a resource type, which is a compute resource in that case. And we will apply a DDoS policy for detection as well as for mitigation. Now, the detection policy, this is something that we are automatically tuning to adapt to the traffic patterns and the compute resources for that public IP address resource. And then when those change, we will adaptively tune our detection policy as well. Okay, so now let's figure out what's the status of our DDoS protection now. And you see it is protected. That's all. That's simply it is. That's what we need to do, right? We just click IP protection, enable, and that's all. Customers don't have to do anything else. And this is, by the way, one of the key selling points for Azure DDoS protection SKUs. Customers don't have to be DDoS experts, right? Yeah. So this is how to enable the protection. Now let's take a look at some of the telemetry that we are offering for the DDoS service. Now, you're going to monitoring and then metrics. And for that public IP address, I want to show you some of the metrics we have. So if you take a look here, you see a lot of telemetry information that you can use. Some of it shows information on the number of bytes or packets that are being dropped or forwarded during attacks, etc. But I don't want to look at those right now. What I want to show you is the DDoS detection policy. And for that, I'm going to select three metrics that we have. The inbound SYN packets to trigger DDoS mitigation. This will be the first one. And then I'm going to add another metric, which will be the DDoS, the inbound TCP packets to trigger DDoS. And then the third one would be for UDP, right? Because I want to protect also UDP traffic. Even though I'm running web applications, remember that customers can launch UDP traffic towards your compute or your application resource, right? It doesn't really matter if the resource only accepts TCP port 443. It doesn't really matter. The infrastructure will also take the UDP packets, and those will be blocked at the host level. So it's important for us to protect against all kinds of DDoS attacks. And you see that's this detection policy. It means that for SYN packets, we are going to monitor the rate of 10,000 packets per second. And if we'll figure out there is a SYN flood coming that crosses that threshold, we are going to kick in mitigation. Likewise for overall TCP packets in traffic, right? If it's coming over 100 packets per 1,000 packets per second, we're going to kick in DDoS mitigation. And likewise for UDP, it will be 20K. Now, these are the initial default values, but they will change as your application starts to carry traffic and it's going to, auto scale in, auto scale out, etc. We are going to adapt those detection triggers. And this is the main difference between onboarding to Azure DDoS protection services and relying on the infrastructure level protection. With infrastructure level protection, those triggers, this policy is fixed with our own defaults, and those are very high. And
No
on top of
fine-tuning.
that,
Yeah,
no fine
no
tuning,
fine-tuning.
no adaptive tuning. And on top of that, you will not be able to see any telemetry. You will not be able to see whether you are under attack or no, which is something you want to see, right? Because if I select now
yeah.
this metric, and let's add a new let's add a new metric and select whether we are under attack or not. And you see this one, which is under attack or not, it will be either 0 or 1, right? 0 means that your resource wasn't attacked by DDoS attack, or if it's 1, it means that it is being attacked right now and we are applying the mitigation. So all of that is available to our DDoS protection SKUs. And on top of that, which I'll not show in this demo, we have a lot of logging information that customers can ingest either to Sentinel or to an log analytics workspace in order to do some research and understand the exact attack patterns and the mitigations that we apply to understand what's happening and if their mitigation works fine.
Perfect. It looks very easy, and I mean, if it's really just one click to protect my virtual machine, I think that's really fantastic.
Exactly.
Cool. I mean, looking a little at the time, I think we could go on and really go even deeper in the configuration and see some things there. But I think in the interest of time, I would suggest that we wrap it up now. But maybe at some point we can really have a dedicated deep dive again on just the DDoS topic. So really, maybe also seeing how it looks like actually if
Exactly.
an attack is actually
we can
happening.
actually run a DDoS simulation attack in real time, and
Perfect.
then go into the logs and do some KQL queries and see what customers are getting and how to work with the DDoS service.
I mean,
It's all about
you
time.
just signed up. You just signed up for one of the next episodes.
Sure, no problem.
Cool, no, fantastic. Thank you. Evren, as always, I think nice introduction, and thanks for raising awareness to this topic. I really wasn't aware that we have over 2,000 attacks a day sometimes. So that's actually pretty scary.
It's a big number.
And everything is automatically mitigated, right?
Exactly, and that's absolutely amazing. And I mean, now that we saw how easy it is, everyone should do this.
And also, like, again, one other thing that I would like to actually just leave the audience with, majority of our customers are already leveraging application gateway SKU today for layer 7. And then they are already leveraging WAF, and then they would like to reduce their cost, for example, on the WAF component, which is a mod security. And then if they enable DDoS protection, which is the network level protection, and then that WAF component on top of application gateway is going to be discounted 100%. So this is something that they need to be looking at, because while they are actually mitigating all these DDoS risks, they're also just reducing their costs. They're optimizing their costs. And then it used to be more complex from enabling it perspective, but as you guys can see, that is actually just with a click
away.
Exactly, one click away. And then as you see that, like when Amir actually just used the single IP, and then he chose the IP level protection, if he had chosen network level protection, the transition to trigger was going to be the same. There's nothing difference between time to take actually just to enable it. It is perfect. So like if anybody reaches out to us, they ask us questions around like how to do it and what are the other options to do that, or we are absolutely just going to be ready to help them. They can go ahead and just start the protection today. Perfect. So please, they can reach out to us. And then we are also just going to have our in the last slide, actually, you can also just put it here on this chat. I would like to actually just share my screen again to show the audience our emails so they can actually just reach out to us. Let me go ahead and just share my screen again.
And I mean, in addition to the emails that you're going to show, the whole LinkedIn profiles are mentioned in the show notes.
Yeah.
So everyone can click on Evren and Amir and connect, and then also
Exactly.
start.
Exactly. Our names are right there, as Holger said. So these are our, email addresses. They can reach out to us if they have any questions, so we can answer their question. We're gonna be we're gonna be actually not only we're gonna be helpful, we are also just going to give them some recommendations on other, Azure products and like policy-driven access, for example, just-in-time access. Why it is important to have a break glass account, for example. Why they need multi-factor authentication, how they can do the best practices on like the VNet, like for example, VNet creation, what they should be doing from, IP allocation, why they need to do that or why they shouldn't do that. So we can even talk about the VNet encryption, which actually just came very recently. There are lots of things that we can do, so they can reach out to us and we're going to be ready to help them.
Yeah.
Perfect.
All right.
Great. So you heard it. Reach out to Evren, reach out to Amir. Thank you so much to both of you. Again, I think I would really love to have another session where we focus on the actual attack and also then take a look at the acoustic cures. I think that would be really, really nice. But for now, thanks for joining. I think we all learned a lot. And yeah, see you next time.
Thank you for having
Thank you.
us.
Thank you.
Thank
Bye.
you. Have a good day.